Thank you.
I still don't see the share button enabled.
I have to send you the presenter privilege.
Yeah. Okay.
Yes, now it will be.
Yeah, I can see it now. Is my voice coming out clean? Is there any echo from my side? It's fine. Okay, great. Thank you. Going to share my screen now. Right. Okay. Should I do a brief recap of what we did in the last session?
I think that will be good, Sudarsun. Like some of them are new today, so it might be a good idea.
Okay, sure. Um, so in the last session, what we did is we just understood, or we just try to understand the healthcare space in general. So I'll just go back those slides to give you some outline. Just give me 1 minute. Yeah. So we started off saying, let's first identify our target. Given the healthcare space is very broad and very deep, we wanted to first choose where we want to start from, right? So what I did is I had grouped different types of stakeholders into the following categories, right? Patients, physicians, providers, pharma, payers, policies, and public. Into 7 groups and grouped them. But this is not a formal group. I just made it because I liked that all these terms start with a P. It was interesting to see that. So patients are the primary stakeholders in the healthcare system because they are the receivers, right? Receivers of care. And physicians are the ones who offer their expertise, and providers are the ones who create the ecosystem for the service transfer to happen. And pharma is a support structure which provides medicines and all other allied services. And the payers come into play when there is a cost incurred for getting a medical service, and who's going to pay that. So that would be the scope of payers. And policies are the governing bodies which control, monitor, and ensure that compliances are met by all the players in the healthcare vertical. So predominantly government and government appointed agencies. And finally, the rest of the group, whoever may have direct or indirect contribution to the healthcare system. So I group them as public. Starting from researchers who create technology, or investors who pour in money, or associations who deliver services in different styles. So these are the different stakeholders we can try to target, and we have to choose the stakeholders that we want to provide, or that we want to create services or products for. If you want to attack all of them together, one lifetime is not enough. So that's the message I gave in the last session. And then we wanted to also identify some of the problems or some of the challenges which stakeholders from different groups face. And so basically we have to understand their pain points, and that will help us create a problem, or I would say formulate a problem, and maybe start working on the solutions to actually solve the problem and roll it out into production, so that the ones who were having that as a pain point can all be benefited. So we identified some example problems from different stakeholders, so that we saw in the last session. And so that took us about an hour to deal with all the details. So that happened in the last session. So in this session, what I'm going to do is to try giving you more details, more pertinent details about different moving parts of the system. And I'm also going to share how Buddy, as a company, dealt with such challenges and obstacles and opportunities, right? So we are in the market from 2013. So we started our business, or we started our company in 2013 with multiple verticals in mind. Actually, we wanted to have our technology explode on four different verticals, but very quickly we figured out that diversifying too early is too dangerous. So we fixated on healthcare, and under healthcare, we chose providers as our primary what to say our target. So we wanted to create solutions for providers, and providers are deeply connected to the payers through a subsystem called revenue cycle management. This is a standard process in healthcare system, and if you search for RCM or revenue cycle management in the internet, you will get lots of information about it. So basically, revenue cycle management is a set of processes that are followed by the hospitals and the insurance companies to settle the bills, right? So it has nothing to do with the patients, it has nothing to do with the physicians directly. So the provider, which is the hospital, has offered the service to the patient, and if the patient was an insurance supported patient, then the payment will be done by the insurance company on behalf of the patient. So the provider will have to create necessary documentation and pitch it as a case with the respective insurance company, which we call the payer, and that is called a medical claim process. And they create all the necessary documentation to support the claim, and the insurance company, on the other hand, processes the claim and finds out reason for rejecting the claim, because that is what they are subscribed to, because they want to cut costs, right? Or they want to reduce their expenditure. So they will try to find faults in the submitted claim in whatever way possible. And despite that, finally, both the parties come to some consensus on what can be claimed and what cannot be claimed, and then the settlement happens in terms of fund transfer from the insurance company to the hospital. So anything, so starting from the medical documentation to the point when the money is back at the hospital, all the processes, all the tasks, all the different schedules, all the people are all assembled into one large system called the revenue cycle management subsystem, right? And the RCM subsystem is heavily manual, or it used to be heavily manual, and that is why everybody takes a lot of time to refund the money to the hospital. And in the US, it's approximately 90 days maximum. Beyond that, you cannot claim anything. The best case is 30 days, worst case is 90 days. In India, I think the average case is 180 days. It used to be. I hope it is better today. So it takes more time in India because um, uh, first problem is manual. Second problem is majority of the material that are being exchanged is non-electronic. So we still send papers to the insurance company, and people on the other side read those papers and revert back with their answers again on paper. So a lot of things happen in papers in the Indian context. I hope some digitization is helping, but there is a lot of work to be done on the digitization itself. But in the US, everything happens electronically. In fact, everything happens in an automatic fashion between the hospital unit. They call it the clearing house. So every hospital will have a small team called the clearing house. They are the ones who will submit the claim to the insurance company and then watch for what is a response back from the insurance company. And there are standard protocols for sending the request and receiving a response. All of these are documented electronic protocols. Uh, so despite that, it takes about 90 days to get things settled there, right? So we found RCM to be very attractive because there was a lot of opportunity to do automation in that space, and the problem is huge, and the problem itself is a $1 billion space, right? So we found it to be very attractive. So we thought, why don't we try our hands in such a setting? See, the co-founders, all of us, there are three co-founders for Buddi AI, and all of us had a technological experience and experience in working with large volumes of data in our previous experiences. So we had worked with millions and millions of documents from the labor market analytics space, which is basically the job postings and resumes. How do you process them? How do you match between resumes and job ads, and how do you solve the problem of recruitment from the employer's point of view, employees' point of view, and government point of view? Because for the government, it is a big problem. They have to ensure that the workforce created in their state is sufficiently employable, and they are also getting employment, right? Otherwise, the government has to pay them dole. I mean, that's the money to support unemployed people. So the objective of the government was to reduce the dole funding by placing people in appropriate jobs. So that is when, Obama, during Obama's first period, so he introduced a program called Smart 2010 that was introduced in New York State, and Smart 2010 was powered by the technology that we developed from my previous company. And then after seeing the success in New York State, the solution got propagated to at least 18 states when I left that company. And I think it's more than that probably today. So we had a lot of experience in handling text documents, and RCM is a space which is filled with text documents. But the only difference is the domain. The domain is different. Instead of resumes and postings, now we are going to see EHRs and other healthcare related documents. So the technology is common, but the domain knowledge is something we had to pick. So we thought, okay, why not? We can pick the domain knowledge and probably apply whatever experience we already have into this new domain and see what comes out of it. So that's how this company was founded. And we started it like that. We started it very humbly, and now we have solutions across the board, not just RCM. We have diversified beyond RCM also. So some of the highlights are we provide explainable AI solutions to RCM automation end to end. So RCM includes four different blocks. So the first is documentation. I've put it as CDI, clinical documentation improvement. Then medical coding, then billing analytics, and finally denial prediction and denial avoidance. So all four larger building blocks um, um, are there, which provide lots of opportunities for automation and AI application. So that is a space we started the company, and we have diversified to other areas also. The other areas are clinical decision support systems, which help the physicians directly to process data about a patient, and spend quality time in diagnosing the patient rather than reading documentation and creating documentation, right? So those aspects are covered in CDSS. And then we also have solutions in the making where we create the documentation automatically. So let's say if a physician has to create the document, usually physician dictates it and their assistant scribes it. Usually that's the process. And sometimes the assistants can also be from different countries. When you send the audio files, and then someone in some other country will transcribe that audio file and create a medical document and send it back. Now with the modern technologies, which has become almost easy to procure, the speech to text technologies from all the giants, made it possible to replace the transcription industry, which was human powered, into almost automation. So I think 80 to 90% of transcription is done automatically, and the last 10% is probably done using humans to verify and validate the text come out of transcription, right? And so we are moving the pointer ahead. So what we say is, let's do the transcription live. I mean, you don't have to send the recordings elsewhere and get the transcription done and validated. But what we say is, we can actually improve the speech technology which is already there for general text, and customize it for medical language, and then have the ability to transcribe whatever the physician is dictating into a live document, into a real document. And that is taking out a lot of pain from the doctor's point of view. So I have spoken to a lot of physicians in India, who actually think documentation is a big deal breaker for them, right? And they were all excited when we said we have a solution for you. You just have to speak to your phone, or you have to speak to a device that we will supply, and that will automatically create a documentation and put it in your EMR system, right? And 100% of the doctors whom I have spoken to got really excited. None of them said no. From that we could clearly understand that this is one of their toughest pain point, right? And the second level of automation we are looking at is, if you supply let's say a radiology image, an X-ray image or a CT scan or an MRI scan, or a mammogram or whatever, and right now there are a group of doctors called radiologists. They sit down and see the image and create the documentation by hand, and there are some assistance tools, but predominantly created by hand, right? And what we think is, we can provide an assistive technology powered by AI and deep learning, which can analyze the images directly and create the draft of the document without much of a hustle, right? It should be possible, and we are already building some prototypes for detecting the COVID patients from lung scans, and we are also developing a technology for identifying the stroke patients using their brain scans and head scans of CT, right? That work is being worked upon already. And finally, we also provide search engines which will allow patient selection for clinical trials, or doing analytics about different patients. Or let's say you have an incoming patient in the ER, and the doctor is not really equipped with experience to handle that patient. If the doctor is provided a tool which allows the doctor to go and search for previous cases like this, right, and how other ER doctors have addressed that patient, that's going to add a lot of ability to the ER doctor to offer a quality service to the patient. So think of it in that angle. So the search engine, which can be used as a part of the hospital, within the hospital, predominantly used by the physicians, doctors, and other stakeholders to take informed decisions based on what has happened in the past, right? And then, of course, if you are in healthcare, you should also do RPA, which is called robotic process automation. I have other slides at the end. I'll give you more details. And then chatbots. This is again, telemetry or telemedicine kind of settings. Chatbots are the modern technology. I mean, it's like instead of you talking to a doctor, you talk to an expert system through a chat mechanism, where you can have coherent dialogues or coherent conversation with an expert system, which is powered by a lot of world knowledge. This is our portfolio right now, right? And moving on, so let me introduce the core technology that we have developed, which is called the contextual lake. So this is a new term, and we have been dabbling about this term for the past couple of years. But if you see, Amazon has introduced a new paradigm called Health Lake. So they have introduced a new product platform called the Health Lake, which actually provides an ecosystem for startups to build applications on top of it, right? Let's talk about it a little later. So what we do at Buddi is called a contextual lake. So which basically is a collection of knowledge graphs. So knowledge graphs is the orchestrated information or organized information which are extracted from unstructured medical charts, right? So medical chart is an unstructured, or let's call it semi-structured document, and you extract information from the medical charts and understand them, appropriately connect the information, and it is possible to create a graph on it, a connected graph on it. And these graphs, when you look at it in volumes, they provide a lot of knowledge about what is happening, right? And contextual lake is a collection of such graphs. It will be an archive, an aggregate of all graphs, from which we can construct a lot of intelligence. We can extract a lot of intelligence from the contextual lake platform. So I'm going to tell you what are the different things which are present in a contextual lake, right? So contextual lake is the progression from the term data lake. So if you look at the progression of how data has been organized at different times, we see that when large volumes of data were created and managed, people use something called data warehouse, which is basically a large storage unit of organized data. And from that data, you do some, search and retrieval to take extract information from it. And based on that information, you take decisions. So that is the final objective. So we have the data, and from that data, can we translate that to actionable insights? That is the general idea. But during the 80s, there was no notion of data science. Data science as a word wasn't very popular back then. And so data warehouse are just to store, archive, and retrieve information about large systems. That is all. So it is just information extraction or dashboarding. So only those applications were possible from data warehouse. So in the 2000 period, when, or let's say early 2000, 2010, I would say. So data science is becoming popular, machine learning is becoming popular, and all those new jargons have come into play, right? Analytics as a word became popular during this time, right? And people dabble a lot about machine learning, data mining. Deep learning was just coming up. It was not that popular yet, but it is just coming out. It has become popularity. It has become popular in the academic community, but not yet in the industrial fraternity. I think mid 2015, 16 time is when deep learning like sweet became very hot. It became very sweet across the board. But the early 2010 period, it was just coming up. But analytics has already become popular. Big data as a word has become popular, and people started to believe that data can be squeezed to generate useful insights. So people started to believe. Everyone believed that if I have data, I have some wealth of information underneath, and I have to go discover it. Right? Everybody believed it. Whether it is true or not doesn't matter. But if I have some data with me, I will believe that this data has some untapped potential, or some wealth of information is hidden inside, which I should explore and extract. Right? That is the mentality of people during that time. So that is when data lake as a term became popular. So usually data lake has already moved from data centers to cloud. So cloud was also popular during this 2011 timeframe, and people started organizing data in the cloud. And when you have a big data setup meant for analytics, data lake served as the underlying data supply platform or data sourcing platform. It allowed you to organize petabytes of data without much of a hassle, right? It was very easy to organize when you have infrastructure like data lake. So imagine data lake is like a logical grouping of hundreds and thousands of disks, right? Imagine you have petabyte or zettabyte of storage available at your disposal, where you can use that storage for archiving all your data, right? So in the data lake was the term popularized by Microsoft, and I think Amazon used S3 as their storage, the keyword for equivalent of data lake, and different organizations try to popularize different terminologies. Right. So moving on to context lake. So what we say is we also want to create a lake, but it is not just data. So what we say is we want to aggregate all concepts and contexts that we could extract from unstructured text and other modalities of data, and all the whatever data that could be incoming. It could be text, it could be images, it could be audio, it could be video, it could be an ECG rhythm strip, it could be anything, or it could be a brain signal, some data or the other. So the idea is the intermediate representation for all these data type is a graph, a contextual graph, right? Which captures the concepts along with relationships. So it is not just extracting the information from the data, it is also connecting the information or interconnecting the information and make it linked, right? Make it a linked data so that it can be represented as a graph. And the moment it becomes a graph, there are a lot of ready-made solutions you can leverage. See, by this time, graph databases have become very popular, right? And Neo4j is one of the popular databases. I mean, every company has their own favorites, right? Microsoft has its own graph database. right? So when you put all graphs into the archive, and can you inference from these large collections of graphs? That is the objective of contextual lake. So this abstracts the extracted connected concepts from the underlying data store and allows you to play with it and interpret them in whatever way you want and extract actionable insights. And every downstream it becomes simpler because we are unifying the way data is represented, which is basically a contextual graph. And downstream applications always assume that their data is going to be represented as a contextual graph. So building an application becomes easier because you don't have to worry about variety of data or format of data. It's always going to be graphs. And that actually simplified the architecture of all our downstream applications. So contextual lake is our trademark, and we are popularizing it, and hopefully it will make some really good impacts in the near future. So let's look at how the contextual lake is actually built out. So I'll quickly spend a few minutes on it. So there are two parts to it. The first thing is the ingestion pipeline. So what are the various things that we do in the ingestion pipeline, and then how do we convert the standardized data into the other modalities? So the ingestion pipeline typically has all these stages. So you have the optical character recognition. These are all like standard problems in any machine learning pipeline, which involves images and texts, right? So the OCR platform is there already, and the OCR platform, right, it's very good today. I mean, if you are supplying an image of a printed text, OCR works like a charm. It might probably retrieve 95% to 98% of the data present in a printed text, I mean image of a printed text. But what happens is, since the data is coming from hospitals ultimately, people scan, rescan, and re-rescan these documents, and the quality of the images deplete over time. If the images, if the picture of the printed document was scanned multiple times, or if it was transformed from one hand to another, the quality of the image deteriorates, right? And also there are still hospitals which are trying to digitize their data, and they use poor quality fax scanners or image scanners, which can actually introduce a lot of noise in the data. So OCR need to be equipped with handling such problems or deformation in the images. That's going to affect everything down the line. So the standard OCR solutions that are available cannot solve all the problems. You will have to make amends to it. So we ourselves have created tools and techniques and methods to improve the quality of the image and also work with noisy data and stuff like that, right? So it's kind of augmented OCR. So likewise, the next stage, once the text is extracted from the images, um, there could be spelling mistakes, and spelling mistakes can be there even from seasoned physicians, right? People write things in a hurry, and they miswrite, or they could pronounce it differently, so the scribe caught it differently. A lot of problems can happen, and as an extraneous reason, spelling mistakes can also happen during the OCR stage. If the quality of a character, if the quality of the image of a character was not that good, instead of a C, it might put a O. Instead of a P, it might put an A. A lot of things can be swapped. The characters or the letters can be swapped, which will introduce spelling mistakes in the transcribed document or the electronic document. So we need to contextually, and we need to understand the grammar of the sentence and figure out what could be the correct spelling for a token or for a term which was misspelled, right? So it is again an involved system. So it's again an augmented system where we use standard spell checkers, right, along with our own modifications and customization on ensuring the spellings are good. And then next stage is the table extraction stage, right? Or it is actually a parallel during the OCR stage itself. So sometimes data coming as images will have structure. It could have forms, it could have tables, it could have multiple column data. You may have border tables, borderless tables, mixed tables. So when we blindly apply OCR on such structured document, we actually lose structure. So what we do is we identify if a text contains structure in it or not, and then based on it, we use appropriate technology to appropriately process them. So we always assume that a page of information may have free running text, may also have tables or structured data in short, and we appropriately process different modalities of this data. So that is another stronger data ingestion pipeline process we follow. I think anyone who is trying to build an ingestion pipeline will have to consider all these as building blocks. But the thing is, we have our own proprietary technology for it. We don't use any public technology or standard open technology only. We use our own technology also. Otherwise, quality assurance is always a pain. The next thing is just quickly finish this also. And once the text is standardized and we run it through a parsing technology, which we call the deep parser, which extracts the clinical concepts from the medical chart, which is basically a data extraction framework, and it identifies different clinical concepts from the document. And then the next step is we standardize the clinical document using taxonomies and ontologies, because the medical world has already published a lot of standardization for the terms used. They call it the terminology service. UMLS is one organization which provides the standardization toolkit and services for the healthcare stakeholders. Right, so we leverage UMLS, SNOMED, RxNorm, and other LOIC and standard taxonomies and ontologies to standardize our clinical concepts. So that way, the concepts and their variations can all be mapped into one concept ID, one unique concept ID, which is going to help all the downstream applications. And once the concepts are standardized, then we explore and find the links. We identify the relationships between the entities that are identified. We recognize the links that are possibly present between different entities identified during the deparser stage. And this is powered by some top-notch algorithm, and that will give us connected information, right? And that connected information is again enriched using our knowledge mine. So which is the accumulated knowledge over the last several years of research. So we have a jumbo knowledge mine. It's basically a very large graph, and we use that jumbo knowledge mine to enrich the graph that is constructed from the EHR to make it complete. And then this is the primary component of the contextual lake. So this gets indexed in the contextual lake, and it allows for building a lot of applications on top of it. So that summarizes the overall core technology of what we do. So I'm sharing all this information with you because you can very well understand how to go from point A to point B, right? So I've just given the names. I've not really opened up how we do it. And how we do it is the proprietary thing, right? So what we do it, I can always share. It's not a big problem at all, because everybody does a variation of this in some way or the other. So consider yourself to be doing all these stages if you are thinking about developing a pipeline or developing a solution consuming the healthcare data in whatever format it could be, right? So generally put, so this is the overall flow. So an unstructured physician note comes in, and that gets converted into a standard structured document where we are able to extract the data elements and the links between the data elements, and then the structured information gets converted to a graph, and all the other downstream applications consume this graph. This is the overall the modus operandi of anything and everything that we do at Buddi, right? And this seems to be a stable way of processing the data. It allows us to quickly develop new products and technologies, assuming graph as the intermediate representation. So you can also do that if you want to, right? Moving on. So let's quickly look at the differences between products and services. So when we conceive a company, so when I say this is my target customer and these are the use cases I want to solve, and do you want to offer this service, offer your capability as a product or a service? This is a question everybody will have to undergo. In the healthcare world, services are predominantly human powered, right? So the services that are happening in India and other countries are all there to cut down on the human processes. See, I had already mentioned, right? Healthcare is age old. It's very stable. All the processes are very stable, and the processes are defined for how to get it done using human beings. Right now, we are in a transition phase where the human powered processes are being tried out with machine also powered processes. So humans plus machines powered processes, that is what we are trying to explore now, right? So there will be a lot of resistance for starters, but eventually this will become a mix of humans plus machines to provide and deliver all the services. So you can also start a service in the healthcare industry, but predominantly it will become human powered because nothing else is understood by the healthcare subsystems or healthcare stakeholders. So and they are very hard to run, because when you have humans to do the job, and you are always going to do it in big volumes, otherwise you will never make profit. So if you look at any healthcare company in India or in any other country who are offering services only, predominantly they will have a battalion of people working behind, right? I'm referring to few hundreds to few thousands. So a battalion of people will be working behind the scene to pull off the service offering. And and hiring is a pain, retaining is a larger pain, and maintaining quality is a lifelong pain, right? And it's extremely hard to run a business which is human powered, right? You can control the behavior of a machine, but it is very hard to control the behavior of a human, generally put, right? So it's very hard to optimize also. And when you are offering human powered services, there is no scope for you scoring an intellectual property, because you are working for somebody. You are working for somebody. You are not even working with somebody. You are working for somebody. So if that somebody is gone, you have no value, right? So there is zero intellectual property opportunity. Third is, it is profoundly captive in nature. So if a large organization is offloading their job to you as a service provider, and they are probably going to hold you captive, they say you cannot offer the service to anybody else. So usually speaking, larger organizations are the only ones who will have multiple contracts with multiple clients. If it is a smaller organization, you will end up becoming captive. So captive means you will work for only one customer. The problem with captive business, the good thing about captive business is you may have sustained income as long as the contract is live. The downside of captive business is it's a single point failure. It's a single point failure. If your client goes down, you also go along. You also go down along with them. It's a bigger problem if you are envisioning your startup as a captive business. So you should try avoiding that setting as much as possible. And finally, if you are in human powered services, either Buddy does it or somebody does it, AI is going to overthrow human power. They are going to displace human power, right? So I am not saying replace, it will displace them. So which means these resources will be repurposed for a different function. So AI will eventually displace the humans or the skilled human labor. It will definitely displace. It is only a matter of time. So next 5 to 10 years, you will see a larger influx of AI solutions in the healthcare space. Large influx of that, and people who were offering services through human powered systems will all change their business model. Either they will change the business model, or they'll close the shop and open a different shop. This is going to be the case. So I suggest, don't think about services. So think about the products. So when you are going to offer something as a product, in today's situation, anything and everything you offer as a product is going to be expected as a SaaS offering. Gone are the days when you are going to install an application in a client site, right? The desktop applications are all gone. I mean, I rarely see desktop applications nowadays. Most of the applications that we see are all web-based, right? And an outcome or manifestation of SaaS, right? So if you are thinking or pondering about products, it is going to be a de facto that your product is going to be in the SaaS model or going to follow the SaaS model. And when it is SaaS model, there are three types of deployments. The first one is called the hosted deployment, where you will hold the entire SaaS in your setup and people will come to you from their application, from their web application or whatever. The requests will come from outside to your network, and you will process the data and get back and push back the results to the end user. That is called the hosted style of servicing. The second thing is called the on-premise servicing, which is you will forklift your suite, the API suite, to a client site. So you will deploy your solution in a client site, again in a SaaS model, and the client will consume your SaaS application inside their premise. So you will have no access from outside. And on-premise is a setting which is the default when it comes to large hospitals. Hospitals usually have their own data center somewhere in a secured area. And if you are going to provide a solution directly to a hospital, and you are talking about on-prem solution, so you are going to deploy your solution physically inside their premise, in a server inside their premise, and you are going to operate from within there. So it's a completely different, it's a different game completely, right? From hosted to on-premise, because in hosted you control everything. If you want to patch your application, you can patch it in no time. But on-premise, you may have to physically go there to patch it, unless they give you secure access, secure remote access. It's actually slightly difficult, right? And the third variation is called the in-subscription variation, which is the data from the hospital is already moved to cloud, their own subscription inside the cloud, and that cloud instance will have a perimeter. So it's a secured LAN for the particular hospital or particular institution, and you will be given access to go inside that particular perimeter network and deploy your solutions inside that network. That's called the in-subscription deployment. So all three follow the SaaS model, but the point of offer changes. So in hosted, you keep APIs with you and you offer the services from your location. On premise, you go to the hospital and deploy it within the hospital. So everything happens within the hospital itself. The third one is the data goes to cloud into their own private subscription, the hospital's private subscription. Consider that as their extended data center, and you are deploying your solution inside the cloud subscription. That is the third style. So on-premise and in-subscription are almost the same. The only good thing is, if it is in-subscription, you can do everything remotely. But the on-premise might call you to go there physically to provide support, right? That's the only difference. And each of them have their own advantages and disadvantages. But the best model is the hybrid model. So the hybrid model, the product hybrid model, which is you'll have the proposal is the heavy lifting of the solution has to be done by an AI application or an AI automation solution, but the last mile should have humans in the loop. So that is called the hybrid system. So this actually do not require the behavior of the end user to change much. See, the end user is used to human powered processes. Now, as a company, you are throwing an idea to the end user saying, hey, you are spending too much money and you are spending too much resources. I will give you an AI solution, or I will give you an automation solution, which is going to cut your cost. You are making that proposal. For them to believe your proposal, and if you ask them to change their behavior from expecting human powered results to machine powered results, there will be a resistance, because they don't, what motivation they have to trust you? They don't have that motivation. So the hybrid approach gives that confidence to the end user, saying, hey, majority of the work is done by AI, so you will definitely have cost cutting, and we also allow humans to touch the results. We also allow the humans to validate and do a sanity check on the results. So whatever comes out of the system is all ensured to be manually audited. At least a portion of the data is manually audited. So that gives a better confidence, better level of confidence to an end user who's switching from 100% manual to an automation system. So 100% manual or 100% human powered to 100% AI will never work. Trust me, we have tried it, it did not work. And that's when we invented this method of hybrid. So where you do the heavy lifting using machines or automation or AI, and always do the last mile with humans. So that way, it's kind of a win-win for both parties. It's a win for the technology partner. It is the win for the data partner, right? So let's talk about one more concern. So when somebody who's used to human powered solutions, and they are always used to consuming the end result, right? The end-to-end solution. So from their point, so I have a business problem and this company is trying to help me solve my problem. At the same time, they're also helping me to cut my cost. So I am used to end-to-end solution. Will this company also give me end-to-end solution? So that is the question any stakeholder or any client, any prospect is going to ask you. So end-to-end solution means it actually means that you have to provide the quality of service like a human powered solution, but you have to pull it off with machines. So it's kind of a very difficult proposition, and that is how that is your USP, right? That is exactly what you are trying to sell to a existing customer, right? So the problem here is, although automation increases the productivity or it reduces the cost, the healthcare stakeholders always expect humans in the loop to do sanity checking, conformance, and quality compliances. See, they have their own quality guidelines that they'll have to adhere to. And so far, they have been adhering to these quality guidelines because everything is human powered and they have defined a process perfectly for humans. Now you are changing the game completely, saying, okay, I will do 90% of the job using machines and 10% of the jobs using humans. So it's going to be slightly interesting to convince them. I mean, if you pitch it appropriately, there is a high chance of converting somebody who's not a believer to someone who wants to believe, right? So the risk that as a technology provider, the risk that you have to take is the following. Even if you provide the best AI solution or the best automation solution to a given problem, you cannot guarantee 100%. That is something we should all live with. So none of the solutions that we might build can be 100% accurate, especially when AI is trying to replace humans for decision making. So if there is a decision problem, let's say classification. Classification is a decision problem, right? Whether this is type A or type B. And humans make the judgment based on some insights, their experience of looking at similar data. And when you make a machine to replace a human there, where machine wants to take the decision, how do you control the behavior? So that's going to be always a challenge, right? So AI solution providers find it extremely hard to provide guarantees or intervals, let's say confidence intervals or accuracy intervals, or any sort of guarantees that you might give to an end customer on quality. So if it is a human powered solution, and people can give you guarantees because you have a proper process to ensure quality, and you based on the process you can guarantee quality to an end user. But if you have AI systems, it's going to be slightly tricky to give accuracy guarantees, and this is where hybrid systems will come to help you, because we said the AI is doing the heavy lifting. So most of the work is done by AI and the last mile is always done by humans. So even if something goes wrong, even if something goes out of control, you have the checks and balances to ensure that the results that you're going to send to the end user is validated. So having humans in the loop is always a good thing. Our objective is to minimize the number of humans in the loop. That is all we are trying to do here. So from a 100% human powered system, if you endorse automation for different healthcare processes, from 100% humans to 20% humans to 10% humans to 5% humans, any lower number is equal to savings, is equal to simpler processes, right? So this is something you'll have to understand as the need from the market, and so based on these needs you'll have to make your propositions. So some of the opportunities I just want to give you. So I've just put down some interesting problems which still remain unsolved. Of course, some of these problems Buddi.ai is also working on, but I would say that the problem is not perfect yet, or the solution is not perfect yet. It is in the making, right? No solution can be 100% accurate. You can probably be 90%, 91%, 92%, and it is still growing. So I've listed some of the problems here. I don't want to describe all the problems because I think I'm running out of time. I have some more slides to touch. So So when you see the video again, just pause on the screen and then just read these terms, and probably search internet, and you will find a lot of useful information searching these keywords, right? And there are there are a lot of companies which are providing solutions at different verticals, right? So especially on the patient side. So patient side, there are a lot of applications which are already very active. For example, if you want to find a doctor, you don't use your telephone directory. You just go to Practo. So Practo is one application which has become very popular to identify doctors in the neighborhood for a specific condition, right? So likewise, interpretation of pathology reports and radiology reports. I know a company called IMI Health, IMMI Health, and they provide solutions for fast interpretation at a very, very cheap price, right? They are based in Chennai only, and they provide interpretation on EKG things and all. If you have an ECG waveform, then you can just take a picture and send it to them, and you'll get an expert opinion within half an hour. So they have actually roped in doctors, and they are providing a bridge for the patients to reach doctors in as small as 30 minutes time, right? And a lot of telemetry applications. So all the health apps you have and all your health bands that you wear, all of them are collecting information about your health, or so-called health information. And if those information are all assembled nicely, a lot of useful things might come up, right? So likewise, each box there is a story, and you can actually think about extending on that story and build your own company or product with it. So some of the common problems that we have in the healthcare industry, I've just listed it down here. So as I said, the data ingestion pipeline starts with OCR, and the one biggest pain point is handwriting. So if it is a printed document, majority of the standard OCRs will do a good job. Even if it is noisy, there are solutions, paid solutions with which you can extract text from it. But if you have handwritten text on the page, it is extremely hard. It is extremely hard to do, but of course there are solutions for handwriting detection also. Azure's machine learning solution does a fairly good job in identifying handwritten notes, but if the handwriting is so bad, then it's humanly impossible to do it. Then forget machines doing it, right? If it's hard for humans to identify what it is, then machines can't do much. And the other problem is there may be handwriting overlays. So in the medical documents, although the original document is printed, right? But there may be overlays where the physician might have put a note, or a nurse might have put a note, an anesthesiologist might have put a note. A lot of overlays may come, and those will be handwritten. And there are markers. I mean, people put ticks, X marks, rounds, they circle some things. How do you catch those information? Right? A checkbox effect, the checkbox event in a form is done in different ways. People circle it, people put a dash there, people put an X there, people put a tick there. Those are like really good challenges, my friends. And then the second thing is, although the speech to text is working like a charm for normal English or normal language, but for medical lingo, it is still in the making. It's work in progress even today. So what we have done is we are trying to develop this complementing technology which will allow an existing speech to text engine to also recognize medical language or medical lingo. And the second problem with speech to text is Indian medical lingo. Think about that. So the English speech to text may not really work very well for Indian context, because in Tamil Nadu we speak English differently, in Andhra we speak English differently, in Bihar we speak differently, in Kerala we speak differently, and each of them have their own local accent to it, and makes it really hard for a speech to text engine to recognize what it is. I'll give you one example. So when I did my BTech program in instrumentation, like several decades back, or two decades back, so I used to have a professor. He used to teach us electromagnetic theory. He's from Kerala, and he taught the entire semester. And he often used the word oleum, right? And During college times, only at the end of the semester we open the book and read. Until then, it is just auditing, right? And I'm always curious about what is that word oleum. And during the last 1 month of the semester, when I opened the book, I figured out that he was mentioning volume as oleum. Yeah, yeah. It took some time for me to even uh, yeah, digest that. Yeah, so oleum is actually volume. So this is the kind of local dialect we are talking about. And if a doctor is going to speak like that, imagine what might happen to speech to text technology, right? So we have to be empathic there and allow for the technology to grow and have the ability to identify what is being spoken, especially the drug names, right? Drug names can be really hard for catching, right? If a doctor says a drug name into me on my ear, I cannot really recognize what it is, right? It's very hard. So think about speech to text doing the same. And the thing is, next problem is spelling correction. This is an ongoing problem. The spelling correction for normal English is very good. For example, Grammarly does a brilliant job, super job, right? It actually changed the way spelling correction and grammar correction works today. And they have actually they are a disruptive technology. I really respect Grammarly for whatever they have pulled off. And try medical text on Grammarly, then you will know the difficulty and the gravity of the problem I'm referring to. And then there are these lookup tables. See, since medical terminologies are very vast in nature, and you will have like lookup tables of millions and millions of words coming from different spaces or different subsects of medical physiology and anatomy and whatnot. And when you are in a memory constrained environment, how do you even operate with larger lookup tables? So there should be ways to figure out scientific methods to leverage leverage their ability in constrained environments. That's still an open problem. It's still an unsolved problem. And the other issue is, again, constrained environments where when we decide to use deep learning models and the models are huge, then it's impossible to deploy. For example, GPT-3 is impractical to deploy, right? In any client side, it is impractical to deploy. It's so huge, so huge. And then finally, we have to also look at how do you get back the intellectual property from a client deployment. We said we are going to deploy it in on-prem mode or in subscription mode, but the application you have deployed there is great, but the data is owned by the client. The insights is always owned by the company. The models are always owned by the company. So when you discover something from the incoming data, some insights if you have extracted, and you need that insight to improve your model next time, right? You have to have a way to get it back. And how do you hash it, or how do you get that data back without exposing that to the client, right? It is your asset. You have all the rights to get it back, but you have to get it back in a secure fashion, right? That is one area still we need to do some research. See, there are federated learning platforms, right, which will allow you to do that, but many healthcare stakeholders do not support federated learning because they think it is intrusive. They still think it is intrusive. um, Federated learning has some life to go when spend on these kind of settings. And there are some more standard problems like how do you handle with noisy data, noisy images, and how do you handle data with noisy labels, noisy annotation, erroneous annotations, and the natural behavior of healthcare data is imbalance, and how do you deal with imbalance? And when the data dimensionality is huge, how do you deal with it? And finally, how can you be fair when you deploy an AI solution? So these are some standard problems. See, when we build data, when we build models from the available data sets usually are skewed. Because the diseases are skewed, the demographies are skewed, a lot of characteristics are skewed. So if you want to build a model blindly on the existing data set, the AI that you are going to end up with will not be fair. It will also be biased. So that will be challenged by somebody at some point in time. So if you want to have fairness in AI, you will have to start thinking about it consciously during the data collection and model building phase itself, because it cannot be fixed afterwards. It has to be fixed before the models are built, or you have to do some thorough compensation after the fact. So those are some problems which we'll have to think about. And finally, the very limited availability of annotated data. is another pain point or another challenge we'll have to mitigate. Right. So this is the landscape of various players in the healthcare space, and of this, I mean, again, I'm not going to explain this in detail. So these are nicely organized into different problem verticals within RCM itself, and not every other problem. It is only the RCM space. So pause the video when you see it next time and understand who are the different players. And Buddi.ai is everywhere. In all these places, we have our positioning. And this is another interesting way of looking at the classification of different service providers based on how they operate, right? The four different dimensions are manual versus autonomous. I mean, is it manual, is it autonomous, or is it a hybrid, or whether it is rule-based or model-based or context-based. So those are the dimensions here, and the different groups, different players are nicely clustered into these four quadrants. Again, you can just have a look at it later and then start ingesting the data to position yourself. I mean, if you are thinking about a startup, you'll have to identify which quadrant you want to take or where you want to be. You have to have a thorough understanding of that. Yeah, moving on. So let's look at why AI. Okay. Professor Satya, can I take another 10-15 minutes, please?
Yeah, Sudarshan, please go ahead. This time I had
Thank you.
planned until
Thank
7:30.
you. Thank you. Okay. So should AI be leveraged everywhere? That is the question we all want to answer, right? So in practice, if you see in healthcare systems, the scope for plain automation is brilliant. And the scope for AI automation is not that interesting. It's not that huge. The reason is very simple, because the healthcare system is meant for human power. It was created for humans to work with humans, right? The processes are created for working with humans. So that is why you will see that automation perfect. Anything that humans do, can I change it to automation? Because this human is doing a mundane task, repetitive tasks. So can the repetitive tasks be replaced by something which can do good in repetitive tasks? Yes, that is perfect. So the plain automation, automating something, no questions asked. Healthcare is full of automation opportunities. But what are the problems which can be leveraged using AI? That is a question you should be very, very clear with, because not all problems need AI for solving. You don't need AI for solving a lot of problems in healthcare, but majority of the problems can be addressed using automation, plain automation. So this is where RPA as a technology comes into play. So RPA stands for robotic process automation. So in the olden days, we used to call macro recording. Right, in the Unix world, you can record a macro even with the as small as the VI text editor. So if you do something repetitively, then you can actually record those steps. So basically, when the moment you on the macro recorder, it will observe what are the keystrokes you are making. Right, and in the more elaborate systems, it will also observe what are the mouse movements, mouse clicks you make. Everything is monitored. Your keyboard, your mouse, all input devices are monitored, and the macro recorder will record everything till the time you press the stop button. And once you have recorded a macro, you can replay it any number of times. So if you are doing a repetitive task of copying something, pasting it somewhere, clicking one button, clicking another button, right, in an application, that can be converted into an automation, and that is what RPA offers. So what RPA does is it allows anybody to configure a robot, or anybody to configure an RPA bot, which is basically a macro recorder, and it observes and it memorizes what are the actions that are taken, and then it can repeat it any number of times without getting tired of it. So RPA is a very cool technology, but RPA has nothing to do with AI. So you'll have to remember that. See, many of the healthcare stakeholders think RPA is AI. RPA is automation. Yes, no questions on that. But AI automation is different. RPA automation is different. So I have a comparison again in the next slide. But let's go through it step by step. Is RPA enough to solve all the problems? Probably majority of the problems, majority of the repetitive processes based problems, majority of the cases where humans do repetitive tasks, their RPA is the way to go. And I'll tell you one anecdote here. It seems for selling an RPA bot in a healthcare unit, the sales cycle time is as small as 6 months. It is just 6 months. If you want to sell an RPA bot to a hospital directly, you just need 6 months of effort, and you can make a sale with a hospital directly if you are selling RPA, because it is very nicely understood by everybody. And also the hospitals want to invest on bots to cut down their manual labor, because they know that they can make a lot of cost saving by putting money in bots. So it's very easy to sell bots in healthcare apparently. But if you are going to sell an AI solution to a hospital, the cycle time is 3 years. 3 years, right? Remember that. We'll come back to that point very quickly. So RPA will not solve all the problems, because RPA cannot improve on its own. See, it is basically mimicking, right? It is a mimicking entity. It is like the parrots. I mean, if you teach a parrot to say a word, it will keep saying the same word, and it won't improve on that, right? So RPA is a mimicking entity. If you tell it what to mimic, and it will perfectly mimic it. No questions about it at all. So RPA plus AI, that's a great combination, because AI gives you the decision making power, RPA gives you the ability to execute commands, and if you combine these two, that's a beautiful combination. And we call it the smart RPA, or we actually call it the contextual RPA, CRPA. So an RPA which has awareness on data, which also knows how to process data. Right now, RPAs only look at processes. So whenever human judgment is required to take a decision, AI can provide a better approximation to the human intellect. I'm still saying it is an approximation, right? If you look at 100 human beings taking a decision on a particular data point, an AI probably can mimic, or AI can probably generalize 70 to 80% easily without much of hustle, right? If you want to take it to 90-95%, yeah, with little bit of effort, you can also take it to 90-95% effort. Definitely possible. So AI can provide an approximation to human judgment on a particular data in a constant environment, but RPAs can't judge, or cannot take decisions, cannot learn to take decisions. That is the differentiator between RPA and AI automation. Let's quickly look at what RPA does internally. So I just borrowed this picture from Akasa. Akasa is one of the popular RPA provider, like UiPath. There's another company called UiPath. They have probably the largest market share of RPA. And Akasha is a new company which has come in, and they're also sweeping the market with their solutions. So I just borrowed this picture from there. And so they have this three-step process. I mean, they observe, learn, and perform. Basically, whatever a macro recorder would do, RPA does the same thing, but in a glorified fashion, right? In a more, better user experience, with a better user experience. So what are the advantages of RPA? It can mimic workflows perfectly, right? It can mimic human behavior also, because it is only recording what a human does. So what happens is, when a human is operating on a terminal, and they enable RPA service or RPA agent to enable it to observe what the human is doing. Basically the inputs, keyboard inputs and mouse inputs, right? It is only observing that, and in context of the application or the screen in which the user is operating, of course. So it actually looks at what are the various actions, what are the various interactions that the human is doing with the machine, and it basically records it, right? So in some sense, it can also mimic human behavior, because a bot recording my style of inputting, and it will only mimic my style of inputting, correct? And if this bot can interact with other bots sitting in other machines, that's a different story, because that is an approximation across all the users. That's an interesting story. Probably Akasha is doing it already, I don't know. And it can also speed up. So RPS can also speed up mundane tasks, the repetitive and mundane tasks. It can always speed up, because if I take 1 minute to finish a click and copy and paste, if the system allows it, RPA can probably do it in 1/10 of my time, if the system allows it. So speeding up is natural. and it can learn by observation. You don't have to program it. You don't have to configure it. You just have to let it watch you. That's all. So it can learn by observation. These are some advantages of RPA. What are the disadvantages of RPA? So RPA has no clue what data it is seeing. It is only monitoring for key inputs from the user with respect to a screen. It is only looking at it. It cannot understand what is there on the screen, right? It cannot learn the decision making ability of a human being. Let's say in a screen you see a picture, and on the right hand side you type the name of the picture. Let's say this is the operation you are doing. RPA can never solve this problem. Just think about it. Even if RPA tries to type something on the right side, on what basis will it type? It has no idea, right? So it doesn't understand how the humans are taking the decision to read the image or to see the image and write a note about the image. So the decision process which the humans do, RPAs cannot learn unless they have the ability to understand data. Today's RPAs do not care about the data. They only care about the process. Just keep that at the back of your mind. And RPAs cannot displace skilled labor. It can only displace not so skilled labor who's doing repetitive tasks. So if some human labor is there who uses knowledge and intelligence to take decisions and click buttons based on decisions or input text boxes based on decisions, RPA cannot replace them, because the RPA does not have the ability. But when you combine AI and RPA together, yes, that is the way to go. That will give you the best of both worlds. And tomorrow's healthcare tech will all be powered by the combination of RPA and AI, right? Just keep that at the back of your minds. Right, some examples of AI taking decisions. So how do you code a medical chart into diagnosis codes, procedure codes, and whatnot? This involves a lot of knowledge. You need to understand the text and make decisions based on the text that you saw. Second is clinical document improvement. So you are trying to bridge the gap. If something is missing in the text, you are typing that content. So which again requires you to comprehend the text, understand the gaps, and provide inputs for the gaps. RPS cannot solve these problems. And let's say compute cohorts from the CT lung scan. RPA cannot do it, right? And generating knowledge graph for summarization, not possible. And predicting if an insurance claim would be rejected by a payer based on the claim data. Think about it. And estimating the readmission of an inpatient. So what is the chance of this patient coming back again? Not possible. But there are a lot of research papers on this topic, by the way. And finally, another example is interpreting the rhythm strip. So the ECG plot, the waveforms, can you interpret it? Can you say if this patient is suffering from some condition, heart condition, just by looking at the EKG strip? Not possible. Right. So finally, we'll just close with the obstacles, some obstacles and how we solved it at Buddi.ai. So I've grouped them into 4 different types of obstacles in the healthcare space. So data, technology, talent, and deployment. So what are the data obstacles? So the first problem is availability. So how do you procure data? Where will you get the data from? Or how can you work with the data? All these are problems. So usually healthcare providers or the hospitals, they will never share the data with you if you go there without reference. Impossible. So if you are a startup with a brilliant idea, or if you have some tools which are working apparently, and if you reach out a hospital to give a sample of data for you to try, it's very hard to convince them, because hospitals will not budge, because they have very, very strong or very strict information security compliances, which they will never dilute for a startup or for a company or for a young group of people. The best way to do it is through channel partners. You can actually partner with a larger organization as a partner, a technology partner, and you can go through the larger organization to get the data from a hospital. That is possible. So the way you do it is you align yourself with a larger company who has contracts with hospitals for procuring data, align with them, strike a deal with that company, become their technology partner for few aspects, and through that company you can procure data. That is the only way you can solve this problem. There are restrictions also, like geographical restrictions, and then there are restrictions with respect to where is the locality of the data, whether it is on-prem or whether it is in sub, right? Those are some limitations that you may have to handle to get your data. So reaching the hospitals directly for getting data is not happening. If you are just a startup or if you are just an younger company, nobody is going to pay attention to you. So strike a deal with other entities. It could be an academic institution or it could be an industrial institution. You just strike a deal with them for technology partnerships and get data through them, right? Initially you will have to live with it, but once you have established yourself as a service provider or as a product company, then people will listen to you and they will actually take risk with you once you have some referenceable clients or referenceable deployments. So that's the only way to go. So patience is the key here. The first 2 3 years of your company, it is going to be extremely hard to get data, but once you have established yourself through channel partnership and technology partnership, yes, you can have your day. Because when we founded the company in 2013, our first real data came in at the end of 2014. So we waited for more than a year to get real data flowing in, and after a lot of struggle, of course. The next thing is the quality, the veracity or the noise level of data. Since the data comes in different formats, different modalities, noise is a real pain. And you should have really good quality data ingestion talent and capability so that you, what to say, you process the data and make it usable. So a lot of pre-processing is required to make a noisy data into a usable data, right? And this requires a lot of experience working with uh, messed up data, and you should have the patience to retrieve usable information from those messed up data. This will test your patient, trust me. This data ingestion will test your patients left, right, and center. A lot of varieties are there. And then if the data is complete, so you may get partial data. This will also become a problem. So when somebody gave you data, they are only giving you snapshots of information that they have collected so far. So it doesn't mean it's complete. So you will have to be cognizant about the completeness of the data when you design something on whatever data is made available to you. So you have to be cognizant about that. And the variety, so different structures, different facilities or different providers have different structures, different specialties. Like let's say if you look at cardiology department, they follow a structure. Anesthesia department follows a different structure. Outpatient ER will follow a different structure. Radiology will follow a different structure. So different departments in a hospital will have different structures, and you need to have a unified way of understanding the structure and have the ability to retrieve information from varied structures, right? And also different physicians document it differently. Their style of writing will be very different, and you need to be aware of those nuances also to do a good job. And finally, data, as usual, will be skewed and truncated. I mean, it can be truncated. It can give you nightmares because of the quality of the data or completeness of the data. So usually the data distribution is always skewed. So don't expect uniform distribution anywhere in real life. If something is uniform, it means something is wrong. So don't trust uniform distribution if it is coming in real life. So always expect skews, always expect disproportionate numbers, always expect um, all weird statistics when you receive data from the real life stakeholders. Due to extrinsic reasons and intrinsic reasons, the data itself is naturally skewed. We cannot do much, but extrinsically also, because they are only giving you a snapshot at that time of snapshotting. That is what they got. So that might not depict the real distribution of data in a client site. So you have to factor those non-stationary distribution assumptions also. And let's look at the talent obstacles. So the problem here is you might be a very, very good engineer, you might be a very, very good researcher, but without the domain skills, it's not useful. It's totally not useful. So a solution has to combine both technology and domain, right? It should combine both. A combination of domain knowledge and technology will make something usable, will end up something usable and tangible. So only technology is useless, only domain knowledge is also useless. And the problem here is finding a cross-functional resource is extremely hard. It's extremely hard. Either the domain knowledge fellows will try to learn technology, or the technology fellows should try to learn domain knowledge. These are the only crossovers that are possible. Those are the only practical ways you can think about. So at Buddy, we have done both. So the technology fellows try to learn domain, and the domain fellows try to learn technology. They have never perfected, but it is better than being in two different bins, right? There is some sort of overlap. It's kind of a fuzzy clustering. You can look at it like that. But finding some resource who's trained on technology and who's also experienced in domain is kind of very rare, very, very rare, right? But that is how it should be. But when you get enough experience in domain along with your technical prowess, you will be a really hot resource. I mean, you will be a very respected resource, because that combination is very rare, especially in healthcare world, right? And the thing is, the ability to transform a real life problem into a technology problem, this is something which is missing everywhere. We have seen people with 5 years, 10 years experience, but they don't know how to translate a real life problem into a technology problem. And there are a lot of, I think, in today's world, 99% of the so-called data scientists do not know how to translate a real life problem into a data science problem. They don't know. If you give them organized data, if you give them structured data, then they will do something. In my opinion, that is data operations, that is ML operations, that is not research, right? That is not really scientific. I mean, you are just using ready-made solutions to pull it off. It's basically ML ops. But when you have the ability to translate a real life problem into a data science problem, that, my friend, is the real flair of intelligence. And that is very hard to find in today's market. So what we do is we catch people who have the potential to learn such traits, and we give them the training by putting them through different experiences. That's all. We just allow them to learn by looking at others. So there are people who already know how to translate the problem, and we allow them to observe how they solve the problem. In the process, we hope that they will also learn how to translate a real life problem into a data science problem. But this skill or this trait of translating a real life problem to a data science problem, if you have it, right, you are a rock star already. And if you don't have it, just try to get that into your portfolio ASAP. And technology obstacles. So this is again because of the data availability problems. Majority of the so-called technical superheroes have no exposure to healthcare. See, for instance, the top universities in the country, in different countries, they don't solve a lot of healthcare problems. Why? Because they don't have data. They are not getting the data. See, there is a lot of stigma around sharing the data, right? As I mentioned before, hospitals don't want to share the data because they think it is dangerous to share. But if you don't share the data outside, how do you get new technology to infuse? You cannot infuse new technology when you don't share the examples, or you don't share the data. But sadly, we still live in a world where there is a lot of restrictions around sharing data. And whatever data that is shared usually is very old, not contemporary, or the sample size is too small. So even if you work on some solutions to it, it might work on that data set, but not in any other data set, right? Those are like some real big problems. So although we have the technology caliber amongst our population, since they are not exposed to real healthcare problems, new technology is not being built. And sadly, new technology can be only built by companies and academic institutions who have access to data. That is all. So it is kind of a very restricted setting, right? It's not really a fair setting, I would say, because the data is not open to public. Until that happens, healthcare will move very, very slow in terms of technology obstacles, solving technology obstacles. So if you want to solve a problem yourself, you are on your own. You are definitely on your own. So whatever open source healthcare solutions that you find online are all based on PubMed. None of it is based on EHRs. Right? There is only one data set which is available called the Mimic 2 and Mimic 3 data set. Again, those are old. right? Super old. Those data points are. And if you build something on Mimic and PubMed, how can that be relevant to today's medical lingo? So it is only an approximation. We can always argue something is better than nothing, right? We can satisfy ourselves with only that statement. But what I'm thinking is, companies who have access to data, they should contribute more to research, and sometimes they should also open up their research to general public, and they should open up some portion of the data to the general public for the public researchers to work on it. And Buddi.ai will be releasing. I think we have released some data points in the past, and we will be releasing some more data points in the future for open researchers to work on them. So we will be releasing some of it before the end of this year, right? And so the other problem is healthcare problems. Other issue is healthcare problems do not have out of the box solutions. None of it will work, and you just only have to you'll have to get creative in solving the problem in whatever way possible. None of the out of the box solutions work in a healthcare setting. Every problem that you get in healthcare is a unique problem. Of course, it could be a small variation of an existing problem, but by itself it's unique. The same problem coming from one customer, if the similar problem comes from a different customer, the settings are very different, the expectations are very different, and overall the problem itself is very different. So there is so much of so much of uniqueness leading to less reusability of solutions, which is making it very hard for technology to progress faster, right? And there are healthcare APIs offered by Amazon, Azure, and Google, but none of it is practical. You can probably build toy applications with them, and you can probably build some simple POCs with them, but none of it can solve real healthcare problems. Nobody uses these APIs to solve their problems in the real world today. Maybe it will take some more time, but as of today, none of the healthcare institutions, none of the healthcare technology providers use these APIs to solve and deliver a solution. Nobody is doing it. And whoever is doing it is all probably gauging their solution, or they are evaluating the market or evaluating the solution. So these APIs are only POC level, not, probably toy experiments level as of today. And we will be releasing our APIs before the end of this year in Azure Marketplace. And these are like spin-offs from production software or production applications which we have deployed in client sites. So we want to open up those APIs into consumable, lightweight APIs, so anybody can build applications on top of it. So we will be opening our APIs in Azure Marketplace before end of this year. So please look out for it. And finally, the deployment obstacles. So as I already mentioned, so we have these multiple ways of providing the solutions, the on-prem solution, in subscription solution, and stuff like that. So healthcare providers will not allow their data to go out of their network. So your APIs will have to go into their network. So when the mountain cannot move to Muhammad has to go to the mountain. So that is what is happening today, right? Data is the mountain, API is the equivalent of Muhammad, right? So APIs are going towards the mountain of the piles of data, right? Healthcare stakeholders will not allow the data to go out. But the sad news is Amazon and Google, in their healthcare APIs, they are forcing the healthcare stakeholders to push the data outside the network to make the API calls, right? That is not going to really fly high. That's why the penetration of these APIs in real healthcare applications is minuscule. But the nice thing which Azure does is they give you a container which has all the APIs in it, and that container can be deployed within your perimeter network. So which means the data stays within the perimeter network, and that works like a charm. But the problem is, how would you maintain it? How would you provide updates? How do you observe the quality of the solution? So those are some challenges. So Azure has already adapted the forklift idea, where they forklift the APIs to the data, but Google and Amazon are still in their old style of making the healthcare stakeholders to go to their APIs. So if that is the case, they will never build applications with their APIs. It's impossible, because nobody wants to give their data outside. They will not allow the data to go outside. So Buddi also follows In fact, Buddy followed this idea before Azure followed it. Right? We always forklift our applications into the client's environment. So we provide support through remote connection, right? We log into their machine and then maintain the quality of the models and stuff like that. So it's kind of slightly laborious, but that's the only option we have, right? So otherwise the data is not going to flow in. So we'll have to flow the APIs to the data environment. So that's what we do. And how do we acquire intelligence back from there? Federated learning is the only framework which will support it. And there also, in that setting also, you cannot use standard federated learning frameworks because many of the customers don't support it yet. But we can get inspired by federated learning setting to get the intelligence back. So that's why I put one problem in a previous slide about how do you hash intelligence to bring back to your central hub to create updates to the model and such. Yeah, these are the other obstacles. So I'm just going to skip it. Finally, before you start up, so these are some personal advices that I would give you. So if you want to plan a startup today, right, ensure that you have a runway for at least 2 to 3 years. Please do that. Or you have some provisions made to support the runway for 2 to 3 years. Because if you're going to start building a product today, it takes at least 2 years to build a product from scratch. Minimum 2 years. Trust me, it will take 2 years. So you cannot think that you'll build a product in 6 months and start selling on the 7th month and make your money on 8th month and you'll become profitable in 1 year. It cannot happen that way. It takes at least 2 to 3 years to see your first prospective customer. So ensure you have a runway, please, because a lot of startups die because they don't foresee the problems in having a runway. And if you are thinking about a startup today, please plan your runway and then start your startup. And if you are just a techie, learn sales, please. You learn sales. Without sales, it won't fly. You cannot be a techie to have a company. You need a sales. You need sales prowess to get money. Only then you can sustain your business and run it as a business. And an idea is not enough to start a company. You need to have a full plan for end-to-end plan. Only then you can actually think about starting a company. And finally, if you cannot convince somebody with your idea, please defer it until you can. Right? See, convincing somebody is very important because that will allow you to get investments, that will allow you to get talent. Because if you cannot convince a person to work for you, how will you develop your technology? So you need to know how to convince others. You need to know how to sell your dreams, sell your ideas, right? For getting the money in terms of investment, for getting the talent in terms of hiring, and finally to make a sale. For all these three objectives, you need to know how to sell your dreams and how to sell your ideas. If you're not very confident about selling your ideas today, gain that confidence, feel confident, then think about starting up the company. So with that, I end this lecture, and my best wishes for all of your startup ideas, and I hope many of your ideas convert into a startup company. Thank you very much.
Thank you very much, Sudarshan. That was a very wonderful session. A lot of information. I will definitely upload this video for you to look and read. We may have time for one question if somebody wants to ask.
Hi, Sudhar, Chinappa. Thanks for the enlightening and very stimulating presentation, right?
Chinna, you can speak up a little bit more.
Yes, could you hear me now? Is it audible
Yeah, it's
now?
actually feeble.
Just give me a sec.
I think we lost him.
Hi, Sudhar. Very good evening. Good to see you. Thanks for your kind of very stimulating presentation. Really enjoyed. I felt